Okay guys, so this is my second time recording this because I messed it up the first time. So if you feel like you're losing at this stuff, do not stress because we are all losing at it, okay? We're just doing our best. All right, so on this from October 30th, not October 30th, from October 26th, you see we've got our digital notebook and we've got the answer key. This is going to be pivotal. I want you to work it out on your own, but also check it with the answer key, okay? So that you make sure you've got it right. Okay, so what I want to do first is I want to review what we did yesterday. I did a few of them for you, but I want to review that again. So the first thing we're going to do is I'm going to look at my law of conservation of mass. And all that means is that I cannot create or destroy matter. Okay? So let me do an example with you down here. Really, every time you see the sign that looks like an arrow sign, it means yield. So you can just imagine that it's an equal sign. Okay? So just imagine every time you see an arrow, it's an equal sign. And then it turns into like third grade math. See right here, you've got 35 plus 50 equals 45 plus what? So 35 plus 50 equals 85 equals 45 plus blank. So we do 85 minus 45, and we get the answer should be 40. Okay, so you would come over here and number 9 would be 40. Same thing here, 78 plus 64 is 142. And 142 equals 40 plus blank. 40 plus blank, so I would know that I have to subtract. 142 minus 40 equals 102. Okay? So the same thing over here. For example, 98 grams of iron combines with 26 grams of oxygen. How much iron oxide did we form? So I've got my reactants, my products are coming out. I've got 98 plus 26 equals 124. Okay? So just know that when you look at these, we're all looking at just what's on the left of the equation being what's on the right. So 46 grams of sodium reacts with 70 grams of chlorine. The final product is known as table salt. How many grams do we produce? Add the two together. Okay? So I'm going to erase this. See if I can. Get a big eraser. Okay, now we're going to go into law of conservation of mass, and I'm going to do a few of them with you. Remember to check the key for your answer here. Okay? So let me... Oh, gotta go back to this. And go here. Okay, so now we've got our, I'm going to make this way smaller. Okay, so we've got law of conservation of mass. It says in your own words, what does it mean to be balanced? It means equal on both sides. You can't mix together 100 grams of something and then get out 50. It has to be equal on both sides. Okay? So equal on both sides. And if you have a better definition, by all means, use that. Okay? So let's look at the next page. Basics of balancing. So when you have an equation, there's a few things we can change and a few things we can't change. So chemical equations must be balanced in order to follow the law of conservation of mass. Okay, when balancing, you can only add coefficients. So coefficients are the numbers in front. So they're big numbers. They're not little numbers. They're the large numbers in front of the reactant. Reactant is what you are reacting together. We don't change our subscripts. Subscripts are those tiny numbers that go behind it. So when we write H2O, the 2 is a subscript. We can't ever change those. You can't change those. But you can write a coefficient like 4 out in front of it. That coefficient applies to everything in the compound. So you can imagine, like in math, that we have parentheses around it. And when you have parentheses in math, that means that you take the 4 and apply it to everything. So we have 4 H2s, we have 4 O's. So we multiply. Remember, when you have parentheses, you multiply the number in the front by the number inside. So let's look at some examples of that. Okay, let's look at some examples. We're going to look at examples on slide 18. This is going to be the slide that you're focusing on today, mainly. So let's look at 18. Now, if you click on the little, if you click on, I don't like this color. Let me use this one. So if you click on this right here, remember it tells you all the answers, but I want to go over something for you. I'm going to go ahead and cross these out because they're more complicated and we really don't need to know those. Okay? So right here, we are counting our atoms. So we've got one N, 1, 2, 3 H's. So that's great. Right here, I see a little 2. That 2 means I have 2 H's. I see nothing behind the S, and it's capitalized, so I know it's by itself. And so I have one of those. And then I have 4 oxygens. Now you see a 4 as a coefficient. Remember, a 4 applies to everything. So that means I have 4 of these. So we can draw out 4 of them and count it, or we can just multiply. That means I have 4 times however many carbons I have. I have 1 carbon. So 4 times 1 carbon is 4. And then I have 1, 2, 3, 4 hydrogens. So 4 times 4 hydrogens is 16 hydrogens. And if you drew out 4 of these, you would count 16 hydrogens. Okay, here, this 6 applies to everything in here. Everything that's touching. So 6 times 2 is 12. 6 times 1, remember there's a little 1 there, is 6. Okay? What about right here? I have Mg, and this is all drawn out. Let me write it like this. I have Mg, and then I have parentheses that says NO3 and a 2 out behind it. Okay? That means I have 2 of these and 1 of these. So I have 1 Mg, but I have 2 of this. So let's do it like we do in parentheses. The 2 applies to the N, so I have a little 1 out beside here. 2 times 1 is 2. And then 2 times 3 is 6. Okay, so what about this one? I have 2 ALs right here. And it looks like I only have 1 S, but remember, the parentheses, there's 3 out beside it. So take your little 1, multiply it by 3. 1 times 3 is 3. 4 times 3 is 12 oxygens. Okay, so that is as far as we're going today. If you have any questions, just try to look it back over. This is going to be new. We'll do more of it tomorrow. So just go ahead and make sure your answers look like this. All right? Have a great day.